for. Okay, shall we start?
Yes.
Okay, good morning, good afternoon. My name is Laurent Polidori. I'm the president of ISPRS Commission 3, dedicated to remote sensing. And on behalf of ISPRS, it's my pleasure today to introduce this webinar organized by the working group 3.9 of our commission, working group dedicated to geospatial environment and health analytics, with the support of the ISPRS Student Consortium. Professor Murali Krishna, you are the chairman of this working group, and your efforts contribute to promote the use of geotechnologies, remote sensing, and other digital solutions to health issues. So this is what we are going to see in a few minutes. So thank you and congratulations. And now I think you can present our speakers. Okay, so please go ahead. Thank you very much.
Thank you, Dr. Laurent and Dr. Lakshmi Thapa for all the support. So today we are having, as under this working group 3/9, that is meant for the geospatial environment and health analytics. Especially two speakers addressing different aspects concerned with the environment and health and technology of remote sensing in different perspectives. And let me start with Dr. Asadi Srinivas. He is a visiting professor in the University of Newcastle, Australia. And earlier he was also worked in Liberia in a Blue Crest University. He has about almost 22 years of teaching and industrial experience, and is a member of several professional bodies. And I also constantly monitor him, and I had a lot of contact with him for more than 25 years of the time. And he is very enthusiastic and very cooperative and very much motivated to use the technology for various applications. And I have great pleasure in bringing his topic, generative AI applications, a health perspective. As we all know, the generative AI today leads some sort of a taking to evolving in a very rapid state. So we need to analyze how the technology has developed over a period of the time and where it is going and which are the trends, the setters or the players you need to watch in this particular domain. So generative AI being one of the most important aspects that is going to be covering all aspects of technology. See, today, the people say AI is going to replace jobs. No, AI is not going to replace the jobs. AI is going to replace those people who do not know AI. So that is my firm conviction. And we have today on a very good important topic on emerging technologies for applications. Here is Dr. Asadi Srinivas. I request him to take for about 30-35 minutes of your time and give some sort of a hint of the topic so that we can have few more sessions later on research and applications, etc., in a very detailed manner all over on these webinars, also wherever it's possible in Australia, India, and Europe, etc. So I request Dr. Asadi Srinivas to continue. Thank you.
Thank you, sir, for a nice introduction. Good evening from my side. I'm from Australia right now. Welcome to ISPRS webinar on generative AI applications, healthcare perspective. Why I have chosen this generative AI with the help of Professor Murali Krishna sir suggested you can use AI technology and to do very good research on a health perspective. That's why I have chosen generative AI. So everybody knows artificial intelligence is nothing but science and engineering to develop intelligent based applications. Now I'm using generative AI because we are creating new, which is existing with the help of GAN and VAE, variational autoencoders, and GAN technologies. We are creating innovative ideas, innovative applications by using generative AI. In sort of we are improving the quality of the application, quality of the healthcare perspective. So today I would like to demonstrate a few applications related to healthcare perspective. And everybody knows generative AI is a advanced concept of artificial intelligence, intelligent behavior in a machine, and the science and engineering to develop various kinds of applications in development of audio, video, text, graphics, animation, in terms of quality, in terms of innovative. We are generating various kinds of applications by using generative AI, especially in drug design, in a healthcare perspective, we are using generative AI. By seeing this image, everybody knows that uh, it is an JPG image or PNG image. No. Technically, the jargon of generative AI, which includes all the techniques, tools, AI concepts, everything, we can call it as a generative AI word cloud. So today, I no need to explain all these fundamentals. Everybody knows origins of AI, when it started, and why we are using this AI nowadays important. And we are generating various applications by using machine and deep learning techniques. And the great professor and scientist has given the beautiful definition of artificial intelligence is the science and engineering to make intelligent machines. So AI, it gives the ability to learn, the ability to reason, the ability to solve novel problems, the ability to act rationally, the ability to act like humans, like simulation of human intelligence processed by the machine, especially computer systems. So there are 50 concepts, my dear students and colleagues. We need to start with understand AI types and definition, and you can end with the work on interdisciplinary AI projects, like in an environmental perspective, a remote sensing perspective. You can take as a groundwater PFAS prediction and detection. We are using machine and deep learning models nowadays. Recently, we submitted one paper on applications of PFAS prediction and detection using machine and deep learning applications in Nature Journal. So that's why it is very important. You need to have 50 steps to learn AI so that you can generate various kinds of health related applications. If you see the top AI concepts I have explained, like it starts with artificial intelligence and it ends with edge computing and AI ethics. So in between, various steps we are following in order to implement, in order to develop various kinds of applications. So simply I can say generative AI is a subpart of deep learning. Deep learning is a subpart of neural networks. Neural networks is a subpart of machine learning. So all these are comes under umbrella like artificial intelligence. So everybody knows intelligent behavior in a machine. We are solving various kinds of applications by using machine learning, neural networks, deep learning, and finally generative AI. So generative AI is used to develop new kinds of application which is not existed in the right now. It is generating innovative sort of audio, video, text, graphics, animation kind of applications by using various various concepts like GANs And generative adversarial networks, it is very important concept. Variational autoencoders, very important concepts. And we are developing innovative kinds of applications by integrating with the deep learning techniques like convolutional neural networks, recurrent neural networks, and long short-term memory, LSTM, with integration of various frameworks like in Python programming, we are using Keras, TensorFlow, PyTorch, Scikit-learn, sklearn, Matplotlib, Seaborn, Pandas, NumPy. If we are integrating n number of various libraries and frameworks, we are increasing the quality of the work and improvement of the accuracy in terms of audio, video, text, graphics, animation kind of applications. 20 essential abbreviations you need to understand in order to implement your own applications by using generative AI. So generative AI uses generative adversarial networks, variational autoencoders, and generative pre-trained transformers. Nowadays we are using OpenAI developed ChatGPT 3 and 4. We are generating content of the any latest topic, and we are integrating with the deep learning technique like long short-term memory and auto-regressive models we are using in generative AI. Then comes to the machine learning, you need to have classification, clustering, and association rule mining, outlier detection in three approaches like supervised learning, unsupervised learning, and reinforcement learning. No need to explain, I guess everybody knows supervised learning is nothing but there is a label, there is a target class. Based on the label, based on the supervision, we are classifying the data. The techniques comes under classification, support vector machine, random forest, linear regression, and decision tree, etc. And unsupervised learning is nothing but there is no label, there is no target class, but I would like to classify the data based on the similarity measure. How do we can calculate similarity measure? Based on the Euclidean distance, square root of x1 minus x2 whole square plus y1 minus y2 whole square. Based on that similarity measure, we are classifying the data because there is no supervision. That's why we are using clustering concept. There we are using fuzzy C-means clustering, K-means clustering, fuzzy C-means clustering, agglomerative clustering, density-based clustering, etc. Then comes to the reinforcement learning. So based on the punishment and reward, we are solving the problems, especially in gaming applications. We are using various algorithms under reinforcement learning. Then comes to the data science. We are using data science is the process of extracting meaningful, interested patterns from the huge volume of data by integrating statistical AI, machine and deep learning techniques in order to find out the insights of the given data sets. By using EDA, exploratory data analysis, by using PCA, principal component analysis, by using MSc, AUC, ROC. These all are jargon of data science. Then comes to the natural language processing, study of different languages, study of different linguistics by using various methods like NLP methods, NER, POS, BERT, and RNN we are using in natural language processing. Then comes to the computer vision, study of audio, video, text, graphics, animation by integration of CNN, GNN, generative adversarial networks, augmented reality, virtual reality, optical character recognition, and integration over union. This is about generative AI. So everybody knows now generative AI is a buzzword in the industry, and we are creating new data or content such as audio, video, text, graphics, animation, learning patterns from the existing data sets. So that's why we used to say generative AI is playing a vital role in order to create innovative applications. It is not seen in the existing system. So this is the generative AI right now latest topic. latest concept. So it uses text, audio, video based on content. It has been pre-trained by using ChatGPT, various AI tools we are using. Then these are the top 10 concepts of generative AI, like adversarial networks, variational autoencoders, autoregressive models, transformers, probabilistic graphical models, flow-based models, and EBMs. Especially we are using energy-based models, self-attention mechanisms, and neural autoregressive density estimators, deep generative models we are using. So these are the top 10 models in order to implement audio, video, text, graphics, animation, and satellite images of classification in remote sensing images. We are using these generative AI applications and standards. So these are the top 10 concepts. Just I will give you brief. If you know these 10 concepts, you will become very strong enough to implement various kinds of applications. GAN is nothing but generative adversarial networks. There are two components we are using in GANs, like generator and discriminator, that compete and against each other to create realistic data samples. Whereas in variational autoencoders or neural networks, to encode input data into latent space and then decode it back, generative new data samples similar to the input image, audio, video, text, graphics. Now, transformer models are similar to the neural networks designed to process sequential data, especially natural language processing tasks due to their self-attention mechanism. Then coming to the self-supervised learning, I have explained already, there is a supervision, there is a label, there is a target class. Based on that target class, we are classifying the data, and automatically it can enable them to learn useful representation without extensive labeled data set. That is called self-supervised learning. Then coming to the text generation, if you want to generate a huge volume of data by using ChatGPT, it involving creating coherent and contextually relevant text sequences, often using models like ChatGPT, generative pre-trained transformers. Then sixth concept is image synthesis. I don't have data set. I don't want to download from the free websites, free repositories like UCI, www.uci repositories, or Kaggle or GitHub, but I would like to create my own data set. Go for ChatGPT or any transformers are giving synthetic data, and we can create our own realistic images from scratch or based on specific input, utilizing the techniques like generative adversarial networks and variational autoencoders. We can do the image synthesis. Then coming to the seventh topic, music composition. There are various compositions related to music by involving AI generative musical pieces, often by learning patterns and structures from existing composition. So that is a great thing about music composition. Then we are going to style transformer. It appearance by images by applying visual style of one image to the content of another image, typically using neural networks. Then coming to the data augmentation. So it increases the diversity of training data. Usually we are using 70% of training data, 30% of testing data by applying random transformations such as rotation, scaling to existing data samples, so that we can increase the accuracy and we can increase the performance of the application. Synthetic data generation is nothing but it creates artificial data. That is synthetic data. It can be used to train machine learning models like SVM model, linear regression model, random forest model, and a decision tree model to overcome data scarcity and privacy issues. So these are the top 10 models just now I have explained. So if you want to generate visualizations, we are using two important concepts like GAN and VAE. And how do we can prepare data for generative models? We need to do pre-processing. That is nothing but we are eliminating noisy data, dirty data, inconsistent data, and we are collecting the data, cleaning the data, cleansing the data, and make it suitable for training generative models like generative adversarial networks and variational autoencoders. So there we are using pre-processing techniques. It includes noisy data, missing values, dirty data. We are normalizing data, encoding categorical variables, augmenting data set to enhance model performance. Then there are two important models we are using to implement healthcare applications. Those are GAN and VAE. GAN is nothing but generative adversarial networks can generate realistic images, and VAE is nothing but visualize data distributions, providing insights into data patterns. Pattern is a model. Model is a simplified version of the application and aiding in a decision-making process. So if you see the generative AI for data visualization, we are using various techniques, generating interactive and adaptive visualizations based on user inputs and preferences. That's why it plays vital role in case studies like finance, healthcare, and marketing to derive actionable insights from complex data sets. That's why we are using deep learning techniques, integration of various Python libraries like Keras, TensorFlow, PyTorch, etc., in order to deal with the complex data sets. There are two major libraries we are using, and now I am going to demonstrate various applications of healthcare by using Matplotlib, Seaborn. Matplotlib is one of the great library in Python programming. Integration of deep learning, big data, generative AI, and artificial intelligence, inclusion of machine and deep learning techniques for creating static and animated and interactive visualizations. And then we are going for Seaborn. It is similar to MATLAB, and it gives a statistical data visualization library built on top of Matplotlib, providing high-level interface for drawing attractive and informative graphics. These are the top 10 major applications of generative AI we are using. Finance, especially healthcare. Now I am going to demonstrate practical sessions of various patients' care through visualized medical data and predictive healthcare models, especially nowadays, viral diseases prediction and detection by using machine and deep learning techniques. It is a hot topic right now. We are segregating COVID-19 virus prediction, Ebola virus prediction detection, healthcare especially viral diseases. Then we are going for marketing major application, retail industry, manufacturing and education domain, transportation, energy, telecommunication, urban planning. So in urban planning, assisting in city planning and development with comprehensive visual data analysis we are performing. These are the various case studies. We can use generative AI, especially in music composition, financial forecasting, customer behavior analysis, demand forecasting, healthcare diagnosis and prognosis, fraud detection, virtual worlds, content creation, fashion and product design, music composition, etc. These are various artificial intelligence case studies. We are incorporating generative AI applications and concepts like GAN and VAE in order to develop a new audio, video, text, graphics, animated applications by using this generative AI. These all are case studies nowadays in industry. They are doing wonders for creation, innovative content creation, product innovation, medical insights, language translation, visual support, software engineering, personalized marketing, etc. So in Matplotlib, I am going to generate right now. There are various visualizations like a line plot, scatter plot, bar plot, histogram, pie chart, box plot, and violin plot, heat map, contour plot, surface plot. See, what a wonderful graphs we are creating with the help of Matplotlib. Such a wonderful library is presented in Python programming with integration of machine and deep learning techniques like CNN, RNN, LSTM, inclusion of Keras, TensorFlow, PyTorch, scikit-learn, various visualization libraries we are incorporating to generate various visualizations. See, generative AI is a revolutionized technology right now in healthcare by offering innovative solutions such as personalized treatment plans, enhanced medical imaging especially, and predictive diagnosis. That's why we are going for generative AI in a health perspective. It generates insights from complex data sets. You can't imagine viral diseases data sets nowadays. Okay, so ultimately we are improving patient care and advancing medical research. That's why today's my topic is a healthcare perspective. There I am going to demonstrate with the practical on generative AI and its importance in healthcare. I am using generative adversarial networks like GAN and variational autoencoders and transformer models, especially potential impact on personalized medicine and predictive analytics. I'm using data generation and augmentation in medical imaging. Especially the generative AI helps us. You can create your own medical images, that is called synthetic medical images, to augment training data sets, improving model accuracy, and overcome data scarcity. That's why I'm using generative AI, especially in augmentation in medical imaging. So what are the applications? So we are using in MRI scanning, and computer tomography, CT scans, and X-ray images synthesis. We are using the generative AI models like GAN, WAN, and deep learning models like CNN, RNN, LSTM, with the inclusion of various frameworks like Keras, TensorFlow, PyTorch, etc. For synthesis, image synthesis applications we are developing. So example, I am write a Python program to generating synthetic chest X-ray images using GAN model. See now I am demonstrating this application. So write a Python program. Write a Python program to generate various kinds of applications by using synthetic X-ray images like generative adversarial network and variational auto encoders I'm using. Now I'm demonstrating this application. Please just carefully, you can observe. I'm opening a command prompt and I'm demonstrating applications like medical imagery applications by using GANs and VAE, generative adversarial networks, variational autoencoders, with the inclusion of deep learning techniques like CNN, RNN, LSTM, and Keras, TensorFlow, PyTorch. Various models I'm including in order to improve the accuracy performance. Now, my screen is visible? My dear participants, can anyone acknowledge me? My screen is visible?
Yes.
Yeah, thank you so much for acknowledging. Now I'm demonstrating application like, see here, notepad space. See, Python, very simple for even non-technical candidates, non-technical students. If you know basic mathematics of fundamentals, linear algebra, non-linear algebra from 6th class to 10th class. If you are perfect in mathematics, it is very easy to learn Python. Python is a visualization and interactive programming language. And there are two ways of executing Python programming. One is IDLE and scripting way. IDLE stands for Integration Development Learning Environment. So if you write one command, it immediately responds the output of the command. Scripting way is nothing but where you are writing your own script in order to develop integration of audio, video, text, graphics, animation kind of programming. Now see here, today is date is 26. I have developed various applications. I'm opening this application. My screen is visible. Can anyone acknowledge me? So write a Python program by using PyTorch for a simple generative adversarial network to generate synthetic X-ray images. Now I am going to demonstrate this application. So I'm importing Torch is a machine learning library in Python, and I'm using the generator and the discriminator at a time in order to create new kinds of innovative application. So this is the program. I'm using various activation function like relu, generator, and this is called constructor. There are various methods I'm using, and I'm developing various kinds of functions of this program. Now I'm demonstrating Python space. If you don't have Python, it takes 2 minutes to install Python programming. Just go to Google, download Python software for Windows or Linux. It takes 2 minutes. So like this, if you check like this, you will get it which version I'm using, Python 3.12.4, because my background is computer science engineering. I have done in BTech, Bachelor of Technology in Computer Science Engineering, and Master of Technology in Artificial Intelligence at Indian Institute of Information Technology at Allahabad, and a PhD in Artificial Intelligence in JNTU Anantapur, and a double PhD from Indian Institute of Information Technology in Data Science at it is Allahabad. So that's why I know C language, C++, Java and Python. Right now I'm sticking on Python because it gives more flexible, user-friendly, very easy to write programming. That's why I'm suggesting you, you can choose Python. We have a number of libraries. You can do wonders. Now I'm in IDLE. So you can execute a very simple. A is equal to 3, A is equal to, if you ask what is A value 2, likewise, you can execute your own programs. Now this is called IDLE, integration development. Let's see, simple program. A is equal to 3, B is equal to 4, and C is equal to A plus B. If you ask simple, it will give C output, see, 7. So this is called IDLE. Now I am moving to scripting way. So Python can be executed in scripting way. That's why I have used a Notepad first program. This is a write a Python program to perform PyTorch for a simple generative adversarial networks to generate synthetic X-ray images data set. Now I am executing this program. This is called a scripting way. That means in this Notepad, you can write your own program, your own ideas. You can implement CT scan images, X-ray images, audio, video, text, graphics, animation kind of applications. Any kind of applications by using generative adversarial networks and variational autoencoders. Python space, program, program 26. You need to write program 26 -1. So now I am executing this program. See here, by using PyTorch library, I am taking X-ray images, and see now torch size is I got 1,784. I have taken the images. So this is the program. So this is the program. Write a Python program by using PyTorch library for a simple and generative adversarial network to generate synthetic X-ray images. So we are getting this one. Next, third one, personalized treatment planning. So that's why by using generative AI models to create personalized treatment plans based on patient data, genetics, and historical treatment outcomes. The applications like creating personalized medicine, doses to radiotherapy and treatment plans. Example program, building a write a Python program in simple recommendation system for personalized treatment. Now this is the second program. My dear friends, If you are having any doubt, please ask me so that I can clarify your doubts. So this is the program, second program I am demonstrating. See here my screen. So this is second program, Notepad space. So this is a second program, write a Python program to build a simple recommendation system for personalized treatment. Now I am executing second program, Python space, program 26. See, this is second program. So this is the program I am executing. So before that, I have executed, see, this is the second program. Now I am executing second program. My screen is visible. Can anyone acknowledge me, please? Hello, sir. Can anyone acknowledge me? Okay, okay. I'm getting thumb symbols. See, my recommended dosage for the new patient, 175.0 mg. So that means, see, that warning comes under deprecation of deprecation. You know, in Python, there is a warning. That is not a error. That is not a problem. So likewise, we are executing various kinds of innovative applications. Because of time, I'm running. Please don't mind anything. Then the third one is completed. Then drug discovery and development. So especially generative AI assist in identifying potential drug candidates by generating novel molecular structures. Especially we are using accelerating drug discovery for new diseases. That is the greatness of generative AI. For existing diseases, we have a solution. But what about in forthcoming viral disease? By using this generative AI, we are accelerating drug discovery for new diseases. Example, write a Python program by using recurrent neural network to generate molecular structures. This is the program. Okay, this is the program we are using. Write a Python program by using RNN technique to generate molecular structures. I'm importing TensorFlow. I have explained already in deep learning techniques like CNN, RNN, LSTM are the powerful techniques with the integration of Keras, TensorFlow, PyTorch, Matplotlib, Seaborn, sklearn, NumPy, Pandas, Pillow, etc. Various kinds of libraries we are using. Define, we are importing TensorFlow. From TensorFlow, we are accessing sequential model. We are importing embedding, long, short-term memory and dense. Then we are defining the RNN model, that is called recurrent neural network model. Then in the model is nothing but simplified version of the reality by using sequential model. And then we are performing embedding, that input dimension, output dimension, LSTM we are taking, and then we are performing dense function, and we are using activation function like softmax, relu, etc. This is the output. Because of time, I am moving. Next concept, predictive analytics and early disease detection. So this is also very, very important topics of our today's webinar on generative AI applications in a healthcare perspective. We are applying generative AI models to predict the onset of diseases by analyzing patterns in electronic healthcare records. You give me any data set, I am going to create visualizations like heat map, scatter plot, pie chart, bar chart. Which graph do you want? Please give me data set. I can write Python programming. I can generate visualization on any diseases by analyzing patterns in electronic healthcare records. So especially we are using in applications like predicting cardiovascular events and diabetes risk, etc. Nowadays in India, suddenly 10 years old, 20 years old, 30 years, 40, 50 years, there is no age limit. Everybody is dying with a heart attack. What are the symptoms of a prediction of a heart attack? That is the latest topic. Right now, research is ongoing. We can use generative AI models like generative adversarial networks and variational autoencoders and write a Python program. And we are using uh, these two techniques. Okay, and let me check. My guru is calling right now. Sorry. Okay. Thank you, sir. Now I'm moving natural language processing for clinical data and especially virtual health assistants in chatbots, especially for implementing AI-driven virtual health assistants. Yeah, within 3 minutes, I'm concluding. So, by using generative AI models, especially in virtual health assistants and chatbots, we are using generative adversarial networks and variational autoencoders for real-time patient support and guidance. Especially we are using telemedicine, patient education, and appointment scheduling. We are using this virtual health assistants and chatbots. Write a Python program to perform a simple chatbot using transformer model. Because of time, I am moving. Sorry for then eighth topic is ethical consideration and challenges in general for healthcare. There are few more challenges like privacy concerns regarding patient data. We cannot get patient data very easily until unless we get the permission from the hospitals and government of any country. Bias in data and model predictions, regulatory and compliance issues, need for explainability and transparency in artificial intelligence models. Last but one topic, future trends and opportunities in generative AI for healthcare. So you can enhance your own knowledge in especially in predictive capabilities with advanced AI models like machine and deep learning, statistical, various soft computing models we can use, integration of generative AI in telemedicine and remote care, collaboration between AI and healthcare professionals for better customers outcomes. Then the last see, I'm concluding my session because of time. And if you want to enhance your own knowledge, if you want to do research on healthcare perspective, I'm ready to guide with my supervisor like Ayanki Murali Krishna sir is my godfather and he is my supervisor and whatnot. Summarizing my potential and impact of generative AI in transforming healthcare, the future outlook for AI-driven advancements in personalized medicine, diagnostics, and treatment planning. With this one, if you are having any doubts, please contact me. If you type my name, Dr. Asadi, Srinivasulu in YouTube channel, there are a number of videos I have explained. 300 videos are available in YouTube. Just type my name, Dr. Asadi Srinivasulu. In a healthcare perspective, I have demonstrated various viral disease prediction and detection, in groundwater PFAS prediction and detection, soil data prediction, everything is available. So with this one, I am concluding. If anyone having any doubt, please feel free to ask me any doubts. Thank you, sir, for giving me this opportunity, wonderful opportunity. Thank you, sir. Ayanki Murali Krishna, sir. My dear participants, do you have any doubts? Please contact me. I can do programming in Python. I'm very confident to implement machine and deep learning techniques. My area is in artificial intelligence, machine and deep learning. Thank you, sir, for giving me this wonderful opportunity.
Yeah, thank you, Dr. Asadi, for the overview of one of the important topics, emerging topics today. And I fully appreciate your issue. And I
Thank
stay
you, sir.
back if there are any questions. And I only want to say how the future trends and opportunities in generative AI are going to emerge, which has a very
Yes.
important component you have just highlighted. And
Yes, sir.
though it is a general application with a specific geospatial application, we
Yes, sir.
actually take it to the image because generative has got immense potential to handle the video, images also, text, and not only text, images also. So that is one of the very powerful technologies. So just stay back. If any questions are there, we'll after.
Yeah, sure, sir. I'm
So
ready to handle.
yeah,
Any
now
queries from?
now I request our second speaker, Dr. Satya Sahiti Veeramallu, and she'll be speaking on hyperspectral data for improved land use land cover classification with specific reference to closely resembling classes. So it's quite known the classes are very resembling very spectrally, they're very close. It is very difficult to spectrally classify them because of by using a multispectral data, because they are broadband compared to hyperspectral. Hyperspectral are narrow bands, and with this narrow spectral data coverage, how we can utilize the technology of hyperspectral data after taking the dimensionality reduction, one of the most important aspects. How do you take it forward to classify the closely resembling classes as a very important application? This is a very specific study carried out by Dr. Satyasahiti, and I request Dr. Satyasahiti to make a presentation. She is essentially a senior faculty at Siddhartha Academy of Education in India, and she has got good experience in National Indian Space Research Organization and also Defense Research and Development Lab, and good exposure to the tools. And she has done her master's in the UN Center for the Earth Space Analysis Studies located at Dehradun. And she has a immense basic degree also in geoinformatics. So the entire career starts in geoinformatics. And here we have an expert in hyperspectral data classification, for land use, with reference to the land use, land cover classification. So may I request Dr. Saiti to go ahead, please?
Sir, thank you for the intro, sir.
Please go ahead.
Yes. So good afternoon, everyone. Thank you, Asadi, sir. That was quite insightful. Now, I would like to present my work on, we'll quickly have, in this session, I will be talking on hyperspectral data for improved LULC classification with specific reference to closely resembling classes. I'll start with a small introduction of hyperspectral data, and then we'll jump into some case studies wherein hyperspectral data has been used in various studies for LULC classification. We'll talk about various techniques used in data processing of hyperspectral data. So myself, I'm Dr. Veeramalla Satyasahiti. I'm specialized in remote sensing and GIS analysis. I'm currently working as an assistant professor at SAHE, which is a deemed to be university. So we start with introduction and applications of hyperspectral data, case studies on data processing, atmospheric corrections, dimensionality reductions, field data, ensemble classifiers, and optimum band identification. I would like to say that after my presentation, I would like to give some research ideas where students can actually try out some future scopes of research. So significance of this research area is actually, unlike the multispectral data sets that we are using currently, like Sentinel, Landsat, LIS3, LIS4, all these data sets, they provide information in tens of bands. As you can see here, the data is usually in tens of bands, whereas hyperspectral data contains hundreds of bands within the same spectral range. In the visible and infrared region, the data is collected in hundreds of bands. So the spectral information of hyperspectral data is actually very high as compared to the multispectral data. When we see the spectral curves of different features, like coastal sand, concrete, river water, we can see that in multispectral, it is represented as more like a flat curve. Rather, in hyperspectral data, it is more continuous. So this continuous high spectral information can definitely help in differentiating certain minute characteristics of features. So we start with some of the major applications of hyperspectral data. I made a small comparative study of what multispectral can do and what hyperspectral can additionally do. So we can see here in agriculture applications, as we have told, as it has high spectral resolution. In multispectral, it is possible to identify the crop extent and also if there is any crop disease, but not to a finer detail. Whereas when we come to the hyperspectral data, it has high precision in identifying the crop stress, nutrient deficiencies with high spectral resolution, and also in detecting the type of crop, which is crop classification, crop type classification. Same with the forest species classification or stress monitoring. And coming to the water, your multispectral can actually identify the extent of water and also a broad extent, some of the water quality indicators like turbidity kind of things. Whereas hyperspectral can tell the something which is not visible, kind of things like dissolved organic matters, the nutrients present. So we can go to the finer level when using hyperspectral data. Similarly, in military applications, it can detect large objects when we come to the multispectral data, whereas hyperspectral data can identify the targets, some anomalies in the data, and also it can be used for surveillance. In urban applications also, when using multispectral data, we can tell of course, by using high resolution or high spatial resolution data, we can definitely identify the urban structures. But the material of the structures and the roof structures, concretes, new and old, tar roads, asbestos, these kinds of things can be possible using hyperspectral data, even at a coarser spatial resolution. Coming to the coastal studies also, coral reef extents can be possible using multispectral, whereas in hyperspectral, we can do the health of the coral reef and also detailed analysis of the shorelines. And mineralogical applications, of course, it is one of the majorly used data in mineralogical applications to identify the minerals. So, of course, hyperspectral is a hero when it comes to the identification of minute changes or the properties of the materials. But however, hyperspectral data has certain challenges that we have to address before processing. As I have told you, we will come across certain research areas that are possibly some future scopes of studies when using hyperspectral data. So hyperspectral data, as is having contiguity in the spectral information, it is very much prone to the atmospheric effects, and also the collinearity between bands is very high. So sometimes the same information is repeated in 2 consecutive bands. Also, the volume of data due to the narrow spectral interval is very high. So we have to identify certain algorithms that can deal this high volume of hyperspectral data. Also, the major challenge of hyperspectral data is a mixed pixel effect, wherein the pixels between the 2 different objects will get mixed. The spectra of 2 different objects get mixed because of the moderate spatial resolution and high spectral information, which will lead to mixing of pixels. So this mixed pixel effect has to be addressed. So usually, unlike the multispectral data sets, hyperspectral data definitely needs some radiometric and atmospheric corrections, along with some dimensionality reduction to reduce the volume of the data. And then we proceed to the application part. So this is one of the major pre-processing needed for hyperspectral data. So coming to the LULC part, we have seen many applications in agriculture, forestry, marine, mineral applications, target detections. Coming to the land use, which is a broad area of research because many of the land use studies are being done using multispectral data. Using this fine information or fine spectral information, we have made a study like how LULC can be, how hyperspectral can be an advantage in LULC stream. So because LULC is one of the most common parameter or most common variable that is used in most of the environmental monitoring applications, and obtaining a LULC map accurately will solve many problems related to climate, environment, agriculture analysis, change analysis, any other applications, rainfall predictions, everything. So obtaining a appropriate, accurate, and precise LULC map is a need today. So usually in multispectral data sets, usually earlier land use land cover classification was time consuming and laborious. They used some digitization many years ago. Later on, automatic classification methods have come, remote sensing has come up, and people have started exploring various machine learning algorithms to obtain LULC maps from multispectral data sets. However, there is a high necessity for high spectral information in the data and some advanced classification systems. So this is the major problem that we have addressed. We started with land use land cover classification and we came to hyperspectral data. Why? Because most of the LULC classifications, whatever the algorithm it is, say it machine learning, SVM, ANN, or you call it any binary arithmetic algorithms, we often face a basic challenge. That is, multispectral data has low spectral resolution, and usually the built up is mixed with coastal sand or barren or fallow lands. and your crop is mixed with the grasslands, paddy usually, and your plantations get mixed up with the other roadside plantations, tree plantations, mangroves. So there is a lot of mixing within the land use land cover map. So we thought, why not use a hyperspectral data in order to obtain a accurate land use land cover map? So these are some of the closely resembling class pairs that we have addressed, like coastal sand and built-up, certain plantations. As you can see here, this is the road and this is the coastal sand and some built-ups, all were into the same class. The cyan color represents the silica material or built-up class, but all these were falling in the same class. Similarly, sea water and river water also. This is a list 4 image that we are seeing here. So this is some of the literature that we have studied using various algorithms like hyperspectral and multispectral for forest habitats. Sentinel data were explored, different machine learning algorithms. So after some atmospheric correction methods also we have explored. So after this literature survey, we found out that we have to choose the right method or algorithm for processing the data, and also for classification of LULC, and some wavelengths. We have to identify the appropriate wavelengths where sand will exactly come out. Similarly, where built up will exactly come out. So we have to identify those wavelengths. So I told you that we'll be coming across certain case studies. First, we will see some atmospheric correction methods and some dimensionality reduction methods, then some spectral library generation, then some classifications and classifiers and some ensemble classifiers, and enhancing the spatial resolution using some techniques. These are our case studies or study areas that we considered. One is a mountainous terrain, one is a arid region air-based station, and one is a coastal region mixed built-up. So these are our images. This is a space-borne data. This is an airborne data, and this is an airborne data too. This is a CRIS data, compact high-resolution imaging sensor, which has 18 bands. This has around 242 bands, and this has around 420 bands. This is an every century image of Mangalore region. All the 3 regions are real-time data of India. So this is one of the instruments that we used, ASD field spectroradiometer. So we started with acquiring the data, radiometric and atmospheric corrections. We applied a combinational dimensionality reduction approach. We didn't go for a general PCA, MNF, ICA kind of things, if somebody is aware about it. And then we applied some fusions, then classifications, and an ensemble classification was also applied to obtain a land use land cover map. Also, we have identified the optimum wavelengths in order to, for each of the confusing class, and we made a comparative study about the classification accuracies. So this is a general procedure we do. We can remove the bad bands using some. So we remove the bad bands and then we do the de-striping using averaging methods and negative pixel. If there are any negative pixels in the data, we have to use a convolution-based method to remove the negative pixel. Like if there is a negative pixel here, the surrounding 9 pixels should be averaged and put into the negative pixel, so that we don't get any irregular curves or sudden dips in the curves, spectral curves. Hyperspectral data is more about dealing with the spectral curves of the objects in the image. And then we tried to apply some relative and absolute atmospheric correction methods, wherein we have tested the atmospheric correction methods and found that some flash or at-core based absolute atmospheric correction methods were more reliable as compared to the relative methods, which are only image based. Excuse me. Then coming to the field data collection, we have applied some field spectra. We have collected it using the ASD field spectroradiometer. And then we have improved the classification using some 6 or 7 base classifiers. Using a majority voting technique, we have assembled the 7 classifiers into a single classification system. So this process is called multiple classifier system. As you can see here, we can see there is a sudden dip in the data. This is a spectral profile. And after removing radiometric correction, we can see an improvement. We have just removed it and averaged it using the neighboring pixels. So we have removed the list of bands from all the data sets, and we obtained a final set of 143 bands in Hyperion and 387 bands in Everest NG. As you can see here, this was the curve that we were observing. This was averaged, and this bad line is absent after radiometric correction. Similarly, atmospheric corrections. These are some of the parameters that we have input in Flash and AdCore. We have compared these two absolute atmospheric correction methods because we wanted to see what are the additional advantages in each of these. So we can see here that the sensor altitude is fixed in AdCore. We can only select the sensor and the altitude should be fixed. Whereas in Flash, we can fix the sensor altitude, which is an advantage for airborne datasets. Similarly, spectral polishing also is more reliable in AdCore module, and output reflectance scale values is fixed here, whereas here it is changeable. So this is a comparative analysis of spectral profiles, that is reflectance profiles after atmospheric correction. It is very much important that hyperspectral data need to be atmospherically corrected and converted to reflectance. Only then we work on the classification part, because atmospheric errors are very important to be addressed in hyperspectral datasets. So we can see here this black line, whatever is black, is indicated in is ground truth data. So we need to have a close correlation with the ground truth data. So we applied 6 different relative and absolute methods, and of which we have concluded that the Flash algorithm was producing better accuracies in terms of all the materials that we have considered. We have considered forest, sal forest, tea, barren land, crop, sand, built up and mixed vegetations. Different features were considered. These are some of the land use classes that we have used for classification. We have drawn a regression between the ground data and the image data. So these are some of the atmospherically corrected curves. So after the radiometric and atmospheric corrections, that is a different part of the study. Actually, even during the atmospheric corrections, we faced many challenges, and we also thought that the existing models also need some improvements during the atmospheric correction process, because when we compared 2 to 3 models, we found out some suggestions. After which we came to hybrid dimensionality reduction. Why we have chosen hybrid dimensionality reduction is PCA is a most commonly used transformation method, which will help in reducing the dimensionality of the hyperspectral data. Like that is from the existing 387 bands of Everest NG, it can produce some 8 bands which contain all the information after the transformation. However, some of the hidden informations or smaller informations are missed in PCA. Whereas when we come to MNF transformation, the noise has been very well addressed in MNF. And when we come to independent component analysis, the minute details, whatever were missing in PCA and MNF, are brought out in ICA. So each of these techniques had their own advantages and disadvantages. So we thought, why not we integrate these 3 methods? So I'll show you a small example of what we have obtained. So this is the eigen curve that we considered in order to identify the most dependable components after the transformation of MNF. So you can see here, these are some of the classification results. We have just applied, you can see this is the CRIS image that we used. So this is our hybrid dimensionality reduction method. A unsupervised classification was applied. This is our MNF-based components classified, PCA components classified, and ICA components classified. We have not taken any samples. It is just an unsupervised classification after the transformation. We can see the extraction of the road here. Here it is getting mixed with some other features. Here it was not extracted. As I said, some minute features are missing in PCA. ICA has definitely brought out the minute information, but missing some larger informations. So when we integrated these three, we can see that the extractions were very well done after a hybrid approach. Even our accuracies have improved. You can see it clearly here. Even the extractions of roads, extraction of buildings. So we thought this hybrid dimensionality reduction approach can be a reliable method as compared to a single method, which is like PCA or MNF or ICA methods. However, there is some controversy on using some dimensionality reduction methods because in order to identify the species type or crop type, forest type, minerals, some of the papers have suggested not to use a use a dimensionality reduction method. In our scenario, since it is land use land cover classification, we were not specifically going for minerals or specific property of the material. We went for dimensionality reduction because we wanted the features to be extracted clearly. And during the field visit, I'm trying to show, we have developed a small repository of, since we considered 3 study areas, we have collected using the spectroradiometer. I wanted to show the flow of how to process the field data. So this is how you get a curve. And after getting the curve, these are not atmospheric windows. So this region will definitely have these black kind of noise, so which needs to be removed. So first we do some step-like correction called splice correction. Usually it is in the transitions of SWIR to SWIR2. After the splice, we go for removing the noisy or water vapor regions. And then we go for smoothing of the curve because there will be some aberrations in the instrument as well. So we have to do these corrections, splice, absorptions, and some smoothing in order to obtain an accurate ground truth curve. It is not that just we get the curve from the image, from the ground and directly apply it to the image. The ground data also has to be pre-processed. And then this has to be given as an input to the classification or for resampling of the image. So these are some of the ground truth photographs and spectra that we have collected and corrected. So banana, mango, all this. When we were giving for plantation, we have clubbed these things and given as inputs. These are some ground spectra of concrete classes. Then, so this is the entire library that we have generated. So now, coming to the same topic where we have pre-processed the data, dimensionally reduced, collected the field data. Now our challenge is majorly to address the confusing classes or spectrally resembling classes, class pairs. So I'm just showing the same thing. And now we took the base classifiers and we have given, these are the parameters that we have given. We have fine-tuned them many times in order to obtain a good classification, because as we all know, usually neural networks need a lot of fine-tuning, more number of training samples. SVM was working with very limited training samples. So each one had their own parameter to be fine-tuned. So these are some of the results that we obtained. This is an ensemble result that we got. The same thing, first we did a classification of each classifier and then we have used an ensemble method. We have assessed the accuracies of class-wise accuracies also. Same thing we applied on first, initially it was Hyperion data. Then we applied on airborne data also because we wanted to test it on airborne and spaceborne data sets, as well as in coastal scenario and mountainous terrain. Sir, am I having some 10 minutes more, sir?
5 minutes.
Okay. So I'm actually winding up. So this is one of the ensemble classifications that we have obtained. You can clearly see. So we have seen in our accuracy assessments that SVM was performing well among all the base classifiers. Also, although SVM was performing
Is it disconnected?
Are you okay, Saiti? Is it with you?
I think we lost her connection.
Oh, I
So maybe what we can do when she rejoins is we can ask the questions that are in Q&A to Dr.
yeah,
Srinivas.
we'll take 5 minutes for the questions, 2 minutes to conclude.
Yeah, so we can wait
I'll call
and
her.
do Q&A until
I'll
she
call her. I will
rejoins.
call her. She must have upset seeing this. I'll just call.
Sorry. So should we ask the questions to Dr. Srinivas in the meantime? Sorry, you are in mute, Dr. Murali Krishna.
Yeah, you please go ahead with the Srinivas. We'll come back.
Okay, thank you. So, Dr. Srinivas, are you there?
Saiti. So not Saiti.
Yes, madam. I am there. Any queries from the audience?
Yeah, so
Be brief. Srinivas, your answers also should be brief. Just take 2-3 questions.
Sure, sir.
Yeah.
Sure.
The first question is, it says that, does the use of generative AI techniques for data augmentations such that these augmented images are used to train the model causes the model to overfit?
Yes, very good question. I would like to answer for that question. Yes. So generative AI gives us a solution for augmented image analysis in order to improve the accuracy and performance levels of the quality of the image, audio, video, text, graphics, animation by using generative AI models and variational autoencoders. Yes, we can do it in data augmentation, image augmentation also.
But then what about overfitting? Like, how can we?
Yeah. In order to solve overfitting, we need to do fine-tuning parameters in order to increase the epochs, in order to increase the size of the data, in order to increase the activation functions like relu and softmax, dropout function. There are various fine-tuning parameters are available in order to overcome the overfitting.
So one more question before
Sure.
Saiti starts her presentation. Maybe she can start sharing her screen as well in the meantime. So how computationally efficient the generative AI techniques are in general, like, because like as you said, there are ethical considerations that we need to take care of, and at the same time there are computational efficiencies also, because this kind of ML techniques and the resources it requires is not easily accessible to students or normal persons, right? So how would you like to address, like, how computationally efficient they are in that sense?
For whom this question? For me or Sahiti?
For you. Like, I'm
okay,
asking how
sorry.
computationally efficient generative AI in general.
Can you repeat the question, madam, please?
So the question says that how
Last question.
efficient, computationally efficient generative AI techniques are in general. Computationally efficient in the sense that their computation requires lots of resources which might be expensive.
Yes.
Or which might not be available to students. Let's say we might need server, we might need GPU, like those kind of resources, like how feasible it is for students or laymen to adopt generative AI techniques.
Yeah, sure. So if you want to, student can able to do their mini project, main project in the domain of generative AI, let them take their own image analysis or audio, video, text graphics. First, they have to get the synthetic data from any generative transformers. Once they have data set, then they are going for pre-processing techniques. Once the data is information, then it is validated for suitability of input data. Then they can choose the different models like GAN, WAN, CNN, RNN, LSTM. Then they can use fine-tuning parameters by inclusion of number of input and hidden layers, by inclusion of activation function, dropout function, flatten function. There are various parameters they can do very easily in order to implement real-time audio, video, text, graphics, animation kind of applications.
Thank you. So I think now we need to move towards another
so
presentation before we run out of time.
Yes.
So yeah, so maybe Dr. Saiti, can you continue your presentation?
Saiti, take 2 minutes. Saiti, take 2 minutes.
Yes,
So we have
yes, sir,
questions
sure.
for you.
I think it should be
Okay.
fine. We have like 25 minutes before another presentation starts. So if audience are fine, we have more or less like 15 minutes for Q&A and 5 minutes for presentation.
Okay,
Okay.
okay. You're very kind. I want to be very, facilitate your presentation. So, Saiti, go ahead.
Yes, sir. So, so coming to the accuracies, here also we can see earlier we have seen good accuracy with Hyperion data for ensemble classification, apart from SVM classifier. So one of the major advantage of SVM classifier that we have seen was hyperspectral data first thing has very limited number of pure training samples, and SVM requires limited number of training samples for classification. But whereas in the ANN scenario, ANN requires a huge number of training samples to train the neural network. So SVM was a reliable method with and also performing very well in terms of accuracies and kappa coefficients. And ensemble classification, we have given some weights depending on the classification accuracies. Like we have given for ensemble, what we did was we took all the base classifiers. We have rated them from 0 to 1, 0.1 for least performing, and 1 to the highest performing class. So that way we have fixed an equation which depending on for obtaining a multiple classifier system. So these are some of the most confusing class pairs that we came across: coastal sand, barren land, coastal sand, road in LULC classification. So what we thought was we have to identify the actually responsible wavelengths that are responsible for confusion. So these are some of the regions that we have identified, which will give us good accuracy. So instead of processing, you want to classify only the built-up class, rather than going, and you want to rely on hyperspectral data to avoid confusions, rather than going for entire 400 band processing, you can rely on these 73 bands and obtain a good built-up class map. Similarly, coastal sand can be obtained using these wavelengths, the bands available in these wavelengths. If your multispectral data has these wavelengths, you can go ahead with multispectral. If not, we have to rely on hyperspectral data and these bands. However, we also tested the accuracies of, when we used only these number of bands, we produced the results of classification using 73 bands. The result was like this. And using the selected bands, 54 selected optimum bands, the result of coastal sand was like this. Similarly, we did in a similar fashion for all the LULC classes, all the confusing classes especially. And finally, we calculated the classification accuracy. When we see riverine sand from entire 387 bands, the accuracy was this much. And from the selected bands, the same accuracy was obtained. So this can tell us that optimum band identification can help us reduce the computational complexity and also produce the similar kind of results as using the hyperspectral data sets. So we also tried, some people already posed a challenge that your usually hyperspectral data have a low spatial resolution. So in order to improve the spatial resolution, this is also an area of research where we fuse two data sets, hyperspectral and multispectral data sets, in order to improve the spatial resolution and obtain a spatially and spectrally rich image. We fused CRIS data with LIS4 data. There are certain prerequisites that we need to follow before fusing. So accurate co-registration, same time period. These kind of prerequisites need to be followed. So finally, we obtained some fused images. As we can see here, this is a fused image that we obtained after fusion results. So finally, what I would like to conclude is that rather than relying on a single dimensionality reduction method, it is good to combine or ensemble 3 or 4 methods which have strengths in their own ways, like ICA, which can bring out minute details, and PCA, which can MNF, which can filter the noise. So integrating two or three methods can obtain us good results in terms of even quantitative measures like entropy and SNR values. And in our study, we have concluded that multiple classifier system was more reliable in improving the LULC classification, especially in differentiating the closely resembling LULC classes. Also, our optimum band identification algorithm can be applied in order to identify some of the classes that are of interest, and we can obtain the same accuracy as processing the entire hyperspectral data. And the spatial resolution of the hyperspectral data can be improved using fusion methods. And the future scope of research lies in spatio-temporal transferability of this methodology or this particular spectral libraries that we have generated for 3 different regions. We have to test the transferability of this library. And also many new atmospheric correction models have to come up in order to process different kinds of data sets. And also same thing with the dimensionality reductions. And many techniques, like rather than relying on an external source like a high resolution multispectral data for improving the spatial resolution, we can rather use some super resolution reconstruction techniques in order to improve the spatial resolution of the hyperspectral data. Thank you very much. I hope you found some areas of research from this presentation. Thank you.
Yeah, good. Any questions? Lakshmi, you can go ahead with the questions. So the questions can be.
Yeah, how many participants or students are there, sir, so that we can help them?
Yeah, we'll come back to it later. It's okay. Well, let's first ask the questions. Finish the questions.
Yes, we have tried to correlate the fused data and unfused data. As you can see from the presentation, I'll just share.
Yeah, it is about the fused and non-fused data.
Yeah, yes, sir. We have done that. So can you see here? The entropy of CRIS, we have used 2 fusion methods, entropy HPF and GS. So the entropy has increased after fusion. And also, you can see here, the motto of fusion is to preserve the spectral characteristics and improve the spatial characteristics, which was possible using fusion. See the spectral curve of CRIS and curve of HPF fused method, they were exactly matching. And also, you can see the result of CRIS alone, LIS4 alone, and fusion. We can see some improvements after fusion from CRIS to fused images. I think that has answered your question. Yes, you can please type your question.
Oh, sorry. I was saying it. I was in mute mode. Sorry. So I was asking you, can you please share open sources of hyperspectral data?
You can download some data. I don't think currently Hyperion is available. You can use some Hyperion data, which is available in USGS Earth Explorer.
So Hyperion datasets is
Hyperion,
available
it's
for
of,
free.
yes, it is available of 30-meter spatial resolution, and I think it is around 242 bands.
Yeah, so the next question is by Imrana. It says, did you try to obtain LULC classes accuracy as opposed to overall accuracy?
Yes, we did. We did the overall accuracies, individual class accuracies also. Definitely, hyperspectral data can help in delineating some confusing classes. If you have run Google Earth Engine classification using some Sentinel data or any other data sets, you can definitely try out some new bands or additional bands from Worldview or something. Definitely, the spectral information can help in differentiating mostly coastal sand, barren, fallow with built up. Definitely, it can differentiate.
Thank you. So one more question that was actually by me. So when we say about fusion, does the different spatial variation, like how can we address this varying spatial resolution that exists in hyperspectral and multispectral data sets?
Sorry, I didn't get it.
Because spatial resolution of the
fusion,
hyperspectral datasets and multispectral datasets might be different, right? And you were suggesting about the possible method of image fusion. So how can we address that spatial resolution issue?
Actually, the motto of fusion is to improve the spatial resolution of. Usually, hyperspectral data will have very high spectral information, and the technical specifications of the satellite will not allow for storing high spatial and high spectral in a hyperspectral data. So they will obviously acquire in a moderate spatial resolution of 30 meters and very high spectral information. But when we are processing it, we will have many mixed pixels. So if we can improve the spatial resolution, it will be an advantage. So our main motto is to improve the spatial resolution using an external source. So we should acquire an external source or a high resolution or high spatial resolution multispectral data of the same spectral region and fuse it with the hyperspectral data for the same range, same area, date, everything is a prerequisite. So this fusion methods also will have some influence definitely on the result that we obtain. So we have to try, definitely we have to try 3 to 4 techniques. I really agree with that. Or fuse some techniques. We also tried some microwave data with hyperspectral because there were clouds during the flood time. So that time also we can definitely try some microwave data fusion with hyperspectral data and remove some flood, clouds kind of things. That also helped.
That's really nice. Thank you. So one last question to you, and I would like to request audiences, like maybe participants, maybe they can email you instead because we are running out of time.
Sure.
We have some questions to Dr. Srinivas as well. So why not try other data such as Nmap and Prisma to validate the results obtained from Hyperion?
Yeah, definitely we can try. If we have the if we have same area data, like for suppose Nmap is not available for Mangalore. Similarly, Prisma data is not available for Mangalore. We tried in Indian sites where we visited, like Mangalore is one region, coastal region, Dehradun. So we tried on the available data sets. If the data is available, we can try on all the data sets. Similar kind of experiments can be done and we can validate. Usually, if we validate a hyperspectral result with another hyperspectral result, both can be prone to atmospheric errors, both can be prone to limitations. Rather, if we can validate it with a ground truth or a high spatial resolution image or something which is man-made or with some manual intervention, then we can validate it well.
Thank you so much. So to both of you, to you and Srinivas, Dr. Srinivas, most of the participants, they are asking like if it is possible to share the recorded video in, I mean, we have a YouTube channel, we normally publish video there. Is it okay to publish this video?
Yes, 100%. If you share with me also, I'll feel very happy.
And also the next question they are asking is it also possible to share the slides? And if there is any code, so maybe you can email that to me and I'll be happy to.
My guru, Ayank Murli Krishna sir, I will share to him. He will share with you.
And I can email it to all the registered participants who attended this webinar. So in that way, it will reach to all of them. Thank you.
Sure,
100%.
definitely.
Yeah, thank you. So the question by Israel to Dr. Srinivas is, how expensive is it to leverage generative AI technologies like cost of server, etc.?
Yes, yes. So there is a solution for that reducing cost in a server, because we can take license from the Amazon or any cloud computing environment, so that we can execute n number of applications with reducing cost. Especially even you can use Google Colab in order to implement very good applications, audio, video, text, graphics, in order to reduce the cost of server. So there is a solution. No problem.
So, and then the next question is, the next question is, so it was the one to you. And then there is one more question to, I think, Dr. Sahiti. I think, it is good to answer because I find it interesting. So there is already Sentinel-2 datasets, but why should we be using hyperspectral data? I think it's
okay. I would like to throw a challenge. Let us be online. Let us classify Sentinel data and classify Hyperion data. I'll see 10-meter hyperspectral data can definitely. Can you just classify 17 classes in Sentinel data at a stretch without confusion? Please try it out in Google Earth Engine. If it is available on cloud, 17 classes, 3 to 4 urban structures, 5 kinds of vegetation, coastal sand, fallow, barren, built up. These classes, extremely confusing classes, riverine sand, coastal sand, built up, new concrete, asbestos roads. So can you just, if you draw the spectral profiles, all are very close to each other. Your correlation will be around 0.9, 0.95 between these classes. So when you try to classify using a Sentinel broadband data, definitely there will be some confusions. If you are okay with the confusion and you can do some post classification methods, you can proceed with Sentinel. Rather, if you have hyperspectral data available, that is what in the end, why I have done that optimum band identification is, you can write to Sentinel that, see, these bands are enabling me to identify or to differentiate built up from coastal sand and avoiding confusions during some automatic classifications. So you can include these bands the next time you're launching a sensor. So why not we can try it out?
So so I think we are, I can see there are a few other questions as well, but because we are running out of time, I would like to again request like maybe to email. I can see in the chat box there are like some questions still. So I would like to hand it over to Dr. Murali Krishna. I find both of the presentation very useful. I still have some questions, but I would like to stop it now. And thank you so much to all the participants, speakers, Dr. Murali Krishna and Dr. Laurent, for allowing us the chance to provide technical support. Over to you, Dr. Murali Krishna.
Yeah, I mean, without, there's not we can talk, we can discuss, but due to limited time, I only want to thank both the speakers, and the trends they have established are unique, and these are emerging tools, and there are basic questions on hyperspectral, why hyperspectral to be done when a high resolution satellite data is there. It is as clearly mentioned that the spectrally similar classes, however higher maybe the spatial resolution, cannot be discerned just by a high resolution data. So spectral similarities complicate the entire matter, and we need hyperspectral data. That's what exactly is the message by the Dr. Satya Sahiti. And we have generative AI application, one of the emerging technology, and it has come to stay, and we have to live with the generative AI, ChatGPT, and other tools of Google Bot and all these technologies, LLMs, etc. So it is a high time that we talk more about the geospatial AI, geospatial generative AI, all those things are emerging and going to provide much more meaningful outputs towards achieving the sustainable development goals in an optimum manner. Thank you very much, Dr. Laurent. If you have anything, you can conclude. I just want to say thank the speakers and also Dr. Laurent and our webmaster also. Thank you. Please, Laurent.
No, just thank you. It's over. Just thank you for the two speakers, for the student consortium, Lakshmi, thank you, and Professor Murali Krishna. This is very, very interesting. Every month we have this very interesting webinar. So see you next month.
Yeah, thank you. Thank you very much. You can conclude. Thank you.
Thank you, sir.
Thank you.
Lakshmi